this stuff is so fundamental to the rest of the scores that I want you to have it in front of you to, so you will know, so you can go back and work it and know how to do this. That's why I want to keep it. Jake, come up here and get your paper. Welcome to the 8:35 calculus class. I hear there's one that starts at 8 o'clock, but you must have registered for this 8:35. This would be February the 7th.
So sad about that study group. How about that study group? I'm in.
Arc length. The length of an arc from A to B. I can see it pretty good. Thank you. Is that Josh? Thank you. The length of an arc from A to B, I think, is equal to the integral of the square root of 1 plus f of x prime dx. The f of x prime is the slope of the curve. The length of the arc is equal to 1 plus the slope of the curve and the square root of it. That would be a good candidate for your 3x5 card. I'm going to rewrite this with that square, but I'm also going to just call it y prime square. Hadn't got it listed well. Okay? Now, the problem, here's the problem. That can get real ugly real fast to integrate. Some of the very easiest problems suddenly get extraordinarily difficult to integrate. For example, if y were, say, x to the 4th, y prime is 3x to the 3rd, right? Square that and you get 9x to the 6th. And try to integrate that. You would let u be what's under the radical, right? Is that right?
Yeah.
But you don't have an x for the du. And you need for du, you would need an x squared, an x to the 5th, right? And you don't have one. Do you follow what I'm talking about? If you don't, here, let me.
Well, what about using some sort of implicit differentiation for that?
Can't do it because we're integrating.
Okay.
What I'm saying is, suppose y is equal, did I say x to the 4th?
Yeah.
Then y prime is equal to 3x to the 3rd. Y prime squared is equal to 9x to the 6th. So now the length of the arc is equal to A and B are just two numbers on the x-axis, aren't they? Do you agree? So we're not gonna worry about those right now.
Isn't it 4x to the third?
Say what?
Round is 4x to the third.
It is. Thank you, William. And that's 16. So now that is equal to the square root of 1 plus 16x to the 6th dx. Obviously, by my 5 rules, you'd say let u be equal to 1 plus 16x to the 6th. And du is equal to, that's 60 and 36 is 96x to the 5th. But there is the rub, isn't it? In order to be able to integrate that, wouldn't I need an x to the 5th right where my finger is? So what I'm telling you about arc length is the simplest problem can be really tough to integrate. And right now, you don't know how to integrate much. You know how to integrate easy problems where you don't have to do a substitution. You know how to integrate problems where you do a substitution and can, with a little bit of algebra manipulation, make the original problem change to a new variable. But you don't know what to do with something that ugly. Could I just tell you that right this minute, I don't know what to do with something that ugly. There are some times, and I'll show you this, that you get something in there that you can't do anything with. There are various, I'm going to show you my bag of tricks. The Chapter 8, the much discussed Chapter 8. The Chapter 8 test I would estimate to be 5 times harder than this test. Maybe more than 5, I'm just guessing. Ask Dr. Thomas, he's had a lot of courses, and he said that Chapter 8 test might be the hardest test he's ever taken. And it's not me. It's not me trying to make it hard. This is the real math. But it's in Chapter 8 that I show you my bag of tricks of how to do things like this and handle these. But right now, you don't know what to do with it. And as I told you, being completely honest, without lots of thought, I don't either. But what I'm going to do is I'm going to give you one problem on the next test with arc length. And it's going to be a problem where the function looks sort of strange, but when you take the derivative of it and square it, it will be something that I think you know how to integrate. Do you follow? So I just want you to be able to do the process. And we'll get to the hard stuff later on. Okay? All right, so it's time for an example. And that is, this is example 1 on page 383. And this is the kind of problem you'll see. And this is y is equal to 4 times the square root of 2 over 3. X to the 3 halves minus 1. Do you see what I mean about a strange looking problem? One that's on the board right here that has a very easy function turns out to be a nightmare. But this is one that I would know in advance. When you go through the steps, you'll be able to integrate it with what you know now. Okay? So, let's go through the steps. First thing, even though it looks like a mess, I think you'd agree that there's nothing to taking the derivative, huh? And that is, this, then y prime is equal to 4 times the square root of 2 over 3 times 2/5 times x, you know what I was doing, times 3/2 times x to the 1/2. Do you agree? Could I just tell you on these, about the only way you can mess these problems up is getting too big a hurry. Just take it a step at a time. Just take the derivative, settle for that. The next line I'm going to write is y prime squared. Do you see how I'm building one step at a time? Some of you on that test, Barris, I don't think you'll mind if I pick on you for this. Old Barris wrote that test out, and I want to compliment you, almost all of you. And I don't have anybody to really fuss at about this, about the way you presented the problems on the test. You all did well, including Barris, who doesn't want to kill a tree, who did the entire test on the back of the test. And I might add, did it according to my standards. I didn't have one issue with the way he did it. And all I'm saying is, don't be afraid to put steps in and use a page or two of paper. Okay? So, let's see. Can I do any good here? I can do that much, can't I? So now, y prime squared is equal to 16 times 2 over 4x. Did I just take y prime, whatever it was, and square everything?
Shouldn't be 2/3 instead of 3/2.
No.
No, that's right.
Shouldn't be x over, wait,
We're not, no, because
shouldn't be,
I was taking the derivative, so don't I multiply by the exponent and subtract 1 from the exponent?
shouldn't be x over a quarter though?
Do what?
Shouldn't be x over a quarter though, if you're squaring 1/2? The exponent, or?
Oh, x to the 1/2, x to the 1/2 squared is equal to x to the 1/2 times x to the 1/2, and what do you do with those exponents? And that's x to the 1, isn't it? I bear watching, so I appreciate those questions. Everybody okay with it? Okay. Does that look like 8x to you? Now, do you see why it doesn't that make it just a whole lot easier to deal with? Would everybody agree? Because now I'm going to say, after all of that, I'm going to say that L, which is my original problem, is equal to, and they said from 0 to 1, and notice the problem gave us the limits. You don't have to guess them, you don't have to solve equations simultaneously, they gave us the limits. Okay? The square root of 1 plus 8x dx. Right? Now, what I want you to notice is, that Mr. Grant put all of his wires up. Promise. You can push down in the middle. Put your finger about the middle and push down. Take your hand and push down. I'm trying to make a parabola. Now let me lift your hand up. There's a parabola. Do you agree? And what we're trying to do is, I want to know the length of this piece of wire from here to here. That's what arc length means. Thank you. So what I do is I take that parabola, stretch it out, and put it on a yardstick. Huh?
Yeah.
That's what we're doing. Only those cables on the Golden Gate Bridge, you're not going to be able to stretch those out real easy. Number one, they're in use, right? Number two, they're as big around as my forearm, and I have big forearms. So, you get the idea of what we're doing? So, but now, would you say that's a piece of cake to integrate? So now what I'm going to say is, I'm going to do it like I did in the ones from test one. I am not going to say that what I am about to write is equal to L. I'm just going to work and consider the integral of 1 plus 8x dx. Then u is equal to 1 plus 8x. du is equal to 8 dx. And dx is equal to 1/8 du. And now L, back to the original problem. This is what I was talking about, Daniel, about leaving them off. Now back to the original problem. L, whoops, I'm not ready to go to the original problem. I got to work this one first. So I have 1/8 times the integral of the square root of u du. Huh? Is that right? And that's u to the 1/2, add 1 to the exponent, so I get 1/8, and that would be 3/2, which turns out to be 2/3 out here, u to the 3/2 plus c. That one place, if you were doing it this way and left the plus c off, I might not even notice, and I wouldn't count off, because it's not really part of the original problem, is it? And we're going to make that plus c go away in the next step, right? So now I go back to the original problem, and instead of having to rewrite it, I just use L, and I know what that is. L is equal to, and let's see, that's 1 and that's a 4. L is equal to 1/12 times 1 plus 8x to the 3/2 evaluated at 0 and 1. Did I just tell you by Ms. Voss's standards, I am incredibly sloppy with fractional exponents? she's teaching those students in 97 and 98 to change fractional exponents back to radicals. And I'm telling you, in calculus, if you do that, good for you. But to do anything with it, you're going to have to put it back into rational exponents anyhow.
What do you mean by that?
What'd I do?
That's a 12, right? 1/12, not 1/2?
Yes, thank you. I'll make it a 12 when I get there. Thank you, both of you.
You're talking about turning it back into like 1.5?
I'm not even going to do that. Why? Because I'm substituting numbers into it, right? And that means my answer is going to be a number. So I don't have to make it pretty because it's just going to be a number. Everybody follow? So I think this is equal to 1/12 times, can I just say 9 to the 3/2? Is that okay? And I'm going to leave that 1/12 out here for both of them. And then I have 1 to the 3/2. Is that okay? Everybody? All I did was put 1 in the place of x and then 0 in the place of x and subtracted them. Hadn't we been doing that a long time? A whopping 2 weeks. Okay. Now, here's the way I do it. You do it your way, but here's the way I do it. The first thing that I think of is, what's 9 to the 1/2 power? 3. And what's 3 to the 3rd? 3 times 3 is 9 times 3 is 27. And I don't even have to think about that one, do I? Right? So this is then 26/12, which is 13/6. So what I'm telling you is that piece of wire that I was holding from point to point, we pretended that was this problem. It's obviously not, but we pretended it was. From point to point, I'm telling you that if I took that and pulled it straight and put it on the yardstick, that's what I would get. And that way you engineers can measure how much wire you need to run all the way down East Texas if you're putting in cable TV, huh? Questions?
The problem, what were you given? Just that y equals?
I was given y equals and boundaries for x.
Okay, and they said in between this.
Yes. And that's why I said at the beginning of the problem, in these problems, you don't even have to figure out the boundaries. They're always going to tell you. I want to know one of those wires on the Golden Gate Bridge from the top of the beam to the anchor. I'm always given from and to. Okay? Questions? Now I'm going to work another one. But if you'll just work all of them like that, you'll be fine, huh? There's some more to it. There's no doubt about it. But it has to do with algebra and manipulation as opposed to calculus. But let me show you another case that can come up. Any questions about this? This one is like the test. What that means is that when I make the test out, I'm going to be looking at example 2 on page 383. Beth, could I say it any plainer than that? This is a little bit harder problem, but it's not a little bit harder calculus problem. It's a little bit more algebra manipulation is all it is. I've got f of x. To answer William's question, William said, what are you given? That's exactly what it says in the book. And obviously the right side gives you the limits of integration. And don't write this down. You don't. This has nothing to do with what we're doing. This has to do with understanding about calculus. What if those weren't equal signs there? What if it was x greater than 1 and less than 4? How would that change the problem? It, to what, though?
X is greater than 1 and less than 4.
Hmm?
You're talking about an equal to, if it's not equal to?
Yeah. What if,
You can't use those numbers, you have to go right inside of the number.
It wouldn't be including 1 and 4.
yeah. The answer is doesn't change anything. Why?
Because you're getting the limit anyway?
Yeah. Because remember that stretched S has a limit in it, right? And what's the limit as x approaches 4? 4, huh? Okay? So don't get hung up on that. I think they'll all have less than or equal and greater than or equal. Okay? Here we go. First thing I do is take a derivative. And I think the derivative of x is equal to 3 12 x squared minus 1 over x squared. Is that right? Everybody agree? Okay. Now, f prime of x squared. Does it trouble you at all that on the last problem I used y and y prime, and on this problem I'm using f of x and f prime of x? That shouldn't bother you a bit, should it? Because I've hammered at you enough that the two are the same thing, huh? Okay? So this looks like, is this 3, 6, whoa, I'm squaring. Is this 9 over 144 x to the 4th?
Yep.
And then plus, nope, minus 3 12 plus 1 over x to the 4th. Is that it?
Where'd you talk from?
What did I tell you about my mother? When I had a burn, when I had a wasp sting, when I had a cut, what did she rub on it?
Foil.
Rub foil on it. Square the first term. Did I square the first term? Yes or no?
Yeah.
Square the last term. Did I square the last term? Did I miss it, Travis? Is that what you're about to tell me?
Would it be 2 times 3?
Yeah, there's a 2 in there, isn't there? Travis is right, thank you. Then I multiply the 2 together. I multiply the 2 together. So when I multiply the 2 together, don't those 2 x's divide out? Times 2. And what Travis is saying is that I need a 2 right there.
That 9 over 144, can you write that as 160?
Yeah. Yeah, in fact, thank you for telling me. I was gonna think about that in a minute, what I could do to it.
Yeah, I mean, because that's a,
Ugly?
yeah, well, it's just more, it's larger than it needs to be.
Okay, let's see. What'd you tell me that was?
116.
1/16, x to the 4th, minus 1/2, that's the way it looks to you,
Yeah.
plus 1 over x to the 4th. And here's why I wanted to work this problem. Not that the calculus changes a bit, but unless I had pointed it out to you, there are surely some of you that would have known what to do. But unless I pointed it out to you, some of you might not know what to do. Any suggestions? Any suggestions? Well, let's just keep on going and see what happens. Now, and only now, can I say that the arc length is equal to the integral of 1 to 4 of the square root of 1 plus x to the 4th over 16 minus 1/2 plus 1 over x to the 4th dx.
Can you get rid of the x to the 4th altogether?
No, you can't because of that number in the radical. In order to get rid of the x to the 4th, I'd have to factor it out of every term, and I've got a 1/2 in there.
So if that 1/2 is, let's say, -1 instead, you could?
Say what now?
So if that one, instead of it being 1/2, let's say it was 1, you could get rid of it under the square root, right?
Well, what I'm gonna do, I'm not sure, Josh, I'm gonna put these 2 together, and how does that change the problem?
You threw all the negatives, so you can.
Yeah, doesn't that make it a plus 1/2? Agree with that? So now don't I have the integral from 1 to 4 of the square root of x to the 4th over 16 plus 1/2 plus 1 over x to the 4th dx. Now, we are in trouble, aren't we? Because that's not a nice one to integrate. Wouldn't you dearly love to break it up into separate integrals? But you're not going to do that. You're not going to do that. I went to the cardiologist this week. He said the old heart's fine. Don't be making me have any heart attacks and strokes. You can't do that, right? You can't do that. In fact, there's only one way out of that mess that I can think of. What is it? Try to factor it and hope you get lucky. Try to factor it. What I'm going to do is, off to the side, I'm going to play around with that a little bit. Let me tell you what I noticed. I noticed that if I take the square root of that, I get x squared. I notice if I take the square root of that, I get x squared. So when I multiply them together, like I would with a middle term, I'll have x squared in the top, x squared in the bottom, right? Do you follow? So, off to the side, I'm going to start playing with that a little bit. And I'm going to say, I've got x to the 4th over 16 plus 1/2 plus 1 over x to the 4th. And I'm hoping I want to have something like this. And that's my only chance, because I've got to have inside the square root squared so I can get it out of the square root. So what I'm going to do is I'm going to say this term has just got to be x squared because of the L in full, right? Everybody agree? And this term has just got to be x squared over 4. Do you agree? Now when I multiply these two together, I get x squared over 4x squared times 2. Isn't that the way I do squares? And look what's left. And that's how you factor. How do you know? How do you know if you factored something correctly? Exactly. Shall we? Shall we? I got x squared over 4 plus 1 over x squared. Plus, yeah, times x squared over 4 plus 1 over x squared. First times first, that's x to the 4th over 16. Outside times outside, that is x to the 4th over 4. Oops.
No,
That's the one over
it's
x squared.
x squared.
O is outside times outside is plus x squared over 4x squared. Inside times inside is x squared over 4x squared. And last times last is 1 over x to the 4th. Do you agree? But some nice things are going to happen, aren't they?
Can you explain to me how you get the 2?
What?
How you get the 2x squared?
How did I get what?
The 2 over x.
The 2x squared over the 4x squared.
Yeah.
That too.
How did I get that?
Right underneath your.
This?
Yeah. How'd you get the 2 and the 2 squared?
I said, remember my trick is multiply the 2 together times 2. And I multiplied the 2 together times 2 to see if I got the middle term up here. That's my way of checking it. What we're doing is we're doing the same thing, only we're doing it with 4 because many of you feel better doing it that way. Okay? Now, this one and this one are fine, aren't they? That's what we need, right? And this one, this goes away, and what is 1/4 plus 1/4?
And
1/2. And isn't that what I started with? So what I'm telling you, do you remember what I told you from the beginning? Is that things can get real ugly real fast with arc limits, huh? And this was one where it is sort of a special problem where it can be one that can be factored. Okay? But now that I've showed you this, I will sleep fine the night of test 2, but if I put one like it on the test, right?
So if it didn't factor, you have to do the quadratic formula?
No, not even the quadratic formula, because you're integrating. The quadratic formula says that equals 0. I don't have an equal 0 even. You can't even do that. What you would have to do is you would take what is under the radical, if it wouldn't factor, you'd take the whole radical and do a Taylor series approximation of it, and then you would integrate the Taylor series. That's what you would do. And you'd get an approximation that it could be good to 6 decimal places if you wanted it to be. And we'll do that in Cal 3. That's what we do in Cal 3. But right now, what I'm saying is, right now, you're very limited on what you know how to integrate. So I've got to be careful which kind of problems I put on this test to leave you something you can integrate. And this is the way I can do it, is a problem like this. All you have to do is recognize, when I got to right there, I recognized that I was in big trouble because I couldn't integrate that. At least I didn't think so. And then what I did is I looked at it a little bit more and said there's only one way to get out of this, and that is if what's under the radical is a perfect square. Because then I'm taking the square root of a square, and they both go away, don't they? So that leads me to the next step.
Miles, on the way you do it, you square the first term, square the last term, and then you add 2 last terms times 2.
Yeah.
So you didn't worry about that middle term.
I didn't worry about it in this case because I knew it had better work. But then I went back and checked to make sure that it worked.
So that your way didn't work every time?
No. No, not everything can be factored into a perfect square. All you'd have to do to mess my way up is that. Well, sorry, is that. All you'd have to do, and that would mess my way up. So what I did is I said simply, the only way we're going to be able to work this problem is if I can get a perfect square. So I tried it. I just tried it. I took the square root of that, I took the square root of that, used the sine of the middle, and hoped I'd get lucky. And you will get lucky on the test. Because again, I'm so limited on what you can integrate.
When you do that method, it's you multiply the 2 ends together and you times it by 2, right?
Yeah.
That way it looks like you square it.
That's right, but I would say this, Spencer, the whole purpose of all of this, this is doing it one way, and this is doing it another. I snatched that baby out of the air. It was a little bit more than a pure guess, wasn't it? Because I took the square root of these two. And I said, if I got a chance at all, this'll be it. And then what I did is I squared it. I used foil, wrote it side by side, and sure enough, I got the middle term that I was looking for. But I had to make sure that it worked. And that's sloppy calculus. But the reason I'm doing it is, it's hard to integrate, for you to integrate some of these arc links right now because you don't know some of the advanced techniques of integration. But we're going to fix that in chapter 8, aren't we, Dr. Thomas?
I would say another example you could make would be, let's say you had sine theta involved in it. If you get sine squared theta plus 1 inside the square root,
Yeah.
you get.
That's another one. I'm not going to show them that one because I've spent enough time on it, and I'm just going to give one like this on the test, because right now all I care about is them knowing how to do the technique. But I had to do these two problems for them to understand the technique. But there's a one with the sine, with a trig function that you can get away with using also. Another thing you might do that I bet you thought of that is you could complete the square. You could say, well, I don't know what this is, but I would complete the square. Then in the process of completing the square, you would see you didn't have to add anything to it. It was already where you wanted it to be. Everybody okay with? So I did all of that just to be able to do this step. Do you agree? I did all of that off to the side over there so I could do that. And the reason I wanted to do that is because the square root of something squared is just something, right? And that gets us out of a big jam. Daniel, why didn't I change the limits of integration?
You have to change the variable.
Exactly. Exactly. I didn't bother to write it without the limits of integration because I never did a change of variable, huh? Okay. All right. How do you integrate? Term-wise. Add 1 to the exponent, that's x to the third over 12 minus, that's x to the minus 2, so won't that be x to the minus 1? Minus 1 over x to the minus 1. 1 over x, I mean. That look right to you? And now, See if I did that right, did I? Everybody okay with all that? I think this is 16/3 minus 3/4, no, plus.
Why would you wanna reduce that?
You probably wouldn't. I thought about it as I did it. Why don't we not do that? 4 to the third, 4 times 4, 16 times 4 is 64/12 plus 3/4
3/12.
minus 1/12. What I did is
Oh, you, okay.
I just did those two together. Isn't 1/4, isn't 1 minus 1/4 3/4?
Is it minus 1 though? Because it's -1/1?
What I'm doing is I put these two together and I said 1 minus 1/4, and 1 4/4, 4/4 minus 1/4.
Each left out
You
the,
get 11
That's
plus
just
if you want
negative
to.
1.
That was 3/4 minus 1.
Here's what I'm saying. I said this is 4/4, right? I've got a plus 4/4 and a minus 1/4. How many fourths is that?
3/4.
Hmm?
Well, the plus one, when you subtracted, did you subtract b minus a, it wouldn't be -1 because it's 1 over, it's when you plug it into, it's -1/x.
Oh, right here.
Yeah,
You're
yeah.
asking me about that sign?
Right.
The reason is it already had a negative in front of it. So when I subtracted, this one was negative, and then this one becomes positive. Because remember when you second it, there you go. Your hands told it all. That's why I quit in mid-sentence. Exactly. And so now I've got 63/12 minus 9/12 is 52/12. Is that right?
Would it be close?
No, 54/12, son.
Would it be plus 9
Plus.
12?
Do what?
Plus 9 12? Instead of minus? Is
Yes, of course. Thank you, all of you. 72/12, which is?
Your, what's that for? Oh, never mind. Sorry.
No. Oh, I didn't. I guess that's okay. I can move this, it's okay. I'm gonna go back to the other way I was gonna do it, which is that way. That's what the test question's gonna look like. Really, I hate to say this because I just hate it when math students say it, particularly at this level. Isn't it just plug it into a formula? You write the arc length formula, the arc length integral on your card, and then whatever f of x I give you, you plug it in. Isn't that everything above that blue line, isn't that just getting it ready to plug in? And then you plug it in and get lucky. That's all you can do right now until I teach you how to do problems that you can't integrate. Okay? That's arc length. surface area in 10 minutes. Dr. Thomas, tell them what surface area is about. You gave me the perfect example. Listen to this.
After Katrina, I think they had to repaint the Superdome. Okay?
The roof? Oh, was repainted.
Yeah,
Yeah, they had to replace the roof. Now, how do you figure out the amount of paint to be ordered?
if you're gonna paint a house, how do you know how many buckets of paint? Don't you figure the surface area of what you paint,
Usually let your wife tell you, right?
length times width, and you figure the surface area, and then you look on the paint can and they'll tell you about how many square feet that can is good for, and it depends. Obviously, the more you pay for it, the thicker it is, and therefore it'll go on, you'll have to use more cans. And it depends on, do you want to have a paint job that'll last 10 years, or do you want one that'll last 3 years? Isn't that the drill? But you decide how much paint you need to use in order to, the way you do that is you have to know the area you're painting. Me, my area is 0. I've gone out of the painting business. That's one of the benefits of being old. There's not many, but that's one of them. So what Dr. Thomas was saying is, if you're going to paint the surface of the Superdome, the dome itself, you're going to need to know how many square feet are in it, so you'll know how much paint to order. Only you got to be able to figure the square feet of the Superdome, and that's called surface area. Surface area, okay? You'll use it over and over and over in engineering, because you'll want to design something. Say, for example, you'll want to know one of the things that you and I don't do when we go to buy a car is and professionals that evaluate automobiles measure the surface area of the top of a car. Why? Because that can be used to determine about how many cubic feet are inside the car. Obviously, a Volkswagen Beetle and a Lincoln Town Car have different amounts of surface area. I mean, of volume, space in them, huh? And one way the industry experts evaluate them is by the surface area of the top of the car. But that surface area is not a plane, is it? It is sort of like a parabola that is stretched way out and then turned upside down. You get the idea? And that's another use for surface area. All kinds of things. All kinds of things. Bridges are not flat. They were not flat. Usually they put a little bit of a hump in it for drainage, and usually they drain them off to the side, don't they? To have water go off the sides. And if you're a civil engineer, you're going to have to know how much concrete to order. And that's done by taking the surface area times the thickness of the concrete, and then you get cubic inches of concrete, don't you? Okay? So, what we're going to do for surface area is this. The surface area is that's the way I remember it and have for a long time. But, and that's really all you need to write on your card, isn't it? Because you know what I'm talking about with arc length, huh? But in truth, the right way to write that is just write this on your card. 2 pi immediately comes out front, doesn't it?
Why wouldn't you follow?
Hmm?
Why wouldn't you follow?
Because y is, William said a minute ago, what am I given? And I said, you're given a function. Isn't y that function?
So if it would help, we could write y instead of x instead.
Absolutely. Not only if it'd help, that's exactly what I do when I do it. To me, this looks a lot simpler than putting that f of x prime or in there or anything else. Now, tell me what looks strange about that integral. What? Yeah, 2 variables. I'd say maybe 3, maybe 4 people in this class gave me integrals on that test with u and x in it. And isn't that the big no-no? Not until Cal 4 can you have 2 variables in an integral. But this really isn't 2 variables, is it? Because back to William's question about what are you given, here's example 1 on page 389. 389, number 1. Asked us, find the area of the surface revolved around the curve y equal 2 times the square root of x if x is between 1 and 2. So even though it looks like I have 2 variables in there, I really don't, do I? Because the first thing I'm going to do is do what? Replace the y with its equivalent x value, right? So doesn't that mean that I'll need y prime, won't I? So this is 2 times 1/2 times x to the minus 1/2. Does that look right to you? All I did is take the derivative of x to the 1/2. Everybody okay with that? But that's equal to x to the minus 1/2. And y prime squared is equal to x to the minus 1. Okay? So now the surface area in this case is equal to 2 pi times the integral from 0 to 1 of 2 times the square root of x.
Wait, isn't it 1 to 2?
I'm sorry, what?
Isn't it 1 to 2?
It is. Thank you, Josh. Times the square root of 1 plus 1 over x. Everybody agree with that? Okay? Well, there's 2 or 3 ways to do this one. I don't see a need of keeping you late on a Friday, and I can't possibly finish it, so I'll finish this on, Monday.
Just, where we go, you trying to follow this together here?
Do what?
Are you trying to put these two together, we gonna foil it?
No, not yet, no. No, I'm not. What I'm gonna do is, I'm gonna have to, am I not going to have to do a substitution? The only question is what? You know what I'd be tempted to try? The book does not do it this way. It does not do it this way. What if I let u be equal to square root of x? Then x would be what?
Natural log.
Wouldn't x be u squared?
Yeah.
Oh, yeah.
I might would try that and then see if I could make it something I could get rid of. Or I might would try let u be 1 over x. Then what is the square root of it? X. Wouldn't that be x to the minus 1/2? Anyhow, we'll think about it on Monday. The book has a better way to do it, but the book has a better way. Everybody sign the roll?